Okay, we're talking about startup, what to do when you press the button, and subsequent events after that. Okay, so remember we just covered that pre-startup checklist. Go down that checklist, do all the steps on there. You want to make sure your equipment is in suitable condition to operate. This means it's been installed correctly, the motor's been run by itself, and you've done those pre-startup checks to ensure we're gonna operate successfully. Okay, so we've been through all that, and we're ready to press the button. What to do after saying go? Okay, again, I'm gonna say it again because I can't say it enough. Go through this checklist. We just handed it out. We just talked through it. I would fill it all out. We're looking for that all to be checked. When you get done with startup that day, scan that in, scan that checklist in, show everybody you did everything the right way, okay? Did you go through that checklist? Okay. So you've pressed the button. What next? What next? I would probably start before I even talk about this. I can't go backwards. Um, Before I go into this, where am I going to stand when the button gets pressed? Who's pressing the button? Stand away? I don't want to stand away. I want to be right there, and I want to see what's happening, because you're going to learn a whole lot in those first few seconds. Okay? Yep. I'm listening with my ears. I'm watching with my eyes. I'm smelling with my nose. Is it burning? Is it making noise, sound? What's it feel like?
You hear water. You get the temperature done on your.
Yeah. Okay, so where are we going to stand? I want to be right there. I want to be in range with my infrared thermometer of this stuffing box. So you got it there in your hand. Your form somewhere close by you so you can write down data. But I've got that temp gun right there, Wild West style. I'm ready to pull the trigger on it. Let's see what it's running at, right? But I would have somebody, delegate somebody to press the start command, because oftentimes that control room is 50 feet to 50 yards away.
Yeah.
And you want to be closer. You want to be right there on the pump, okay?
There are more things than you can handle at one time. If it is different locations, you need to have gotten together, and you're going to be there, you're there. Ask the customer, if you got somebody with you, y'all do it, but make sure you got places covered.
I typically have the stuffing box size wrench in my pocket.
Yep. You got your temp gun in one hand. You got your wrench for these packing gland studs in the other. You've already sized it. It's not a crescent. We're not trying to dial this in. We want an open end wrench to tighten that, loosen it, whatever it takes. Snug. You got it hand snug, but not tight. Just hand snug. We actually want to see a little water coming through this stuffing box right from the get-go. Let's let it go for a little bit. Sometimes it'll seal itself. Sometimes you don't need a tighten. I think we jumped to tighten right from the beginning, and that's not really necessary. So let it bubble up a little bit. Let it run like that for a little while. Zero flow means you've cut off the lubrication. You've cut off the flow of water through there. You're going to build heat if you got zero flow. So allow it some water to come through. Like Mario's saying, snug on those gland studs. And then when it starts up, okay, if it was spraying a lot, yeah, I'm going to tighten down on that just a little bit.
Doesn't take much either.
Doesn't take much. Get it, get it a little bit, quarter turn, half turn. Get it to stop spraying so much on you. You don't want to get wet from this, but you want to be ready. And then we're watching, as that valve's opening. That's the most stressful time for that pump, because you got all that thrust from that shutoff valve. That valve shut off, it's pumping against the closed valve. That thrust is at its maximum level. You got all that thrust pushing back against the pump. That's going to throw our shaft out of alignment. And when that shaft's kicked out of alignment in there, you're going to build heat on your bearing. That's why we say this is the most stressful time. and it's also, the time we want to be focused here on that stuffing box. We say this from experience, but we can't tell you how many times that stuffing box bearing has seized on the shaft. Sometimes you can't even control it. Sometimes we're just not prepared. We don't give the shutoff command enough when it comes. So we're going to watch our stuffing box temperatures. I'm going to tell you where to measure the temperature, but I want you to tell me the limit. What temperature is hot? In the past, what they would do, if you could hold your hand there, right? That's kind of your gauge if you didn't have a thermometer. I hope we have a thermometer when we're out there. But yeah, about 160, that bronze starts to swell, and any clearance you had, any water going through, lubricating that bearing at 160, you're swelling. That annular space around the shaft goes away. You know what annular means? Like a donut. Okay. That space goes away, and you don't have any lubrication flow, and that stuffing box is then going to build heat. Okay. All right. So I put this image on to talk about where we record temperature. You got the infrared gun. Would you point it up here on your shaft, on that part of the housing? Where are we pointing it? Yeah, we really want to see what the temp is on that bearing. I'm probably going to shoot it in a lot of places just to tell myself, where's the temperature? Because sometimes that heat can transmit up the shaft. I don't know how good of a reading I'd get here. I just got a really small area of shaft there. That bronze packing gland can rub on the shaft too. Maybe that's getting hot. This housing, this is where the packing is. I guess I wouldn't be so interested in this space right here as I would, maybe right in here. This is might be the closest I can get to that bearing, because what that heat's going to do, it's going to transmit, drawing a blank, conduction, convection, radiation. What are the different types of heat transfer? I think it's conduction. That's going to transfer that heat into that metal and get to that point. So that's as close as you can get to that bearing there, and we're gonna watch that at least through that valve transition period. We're gonna watch that temperature, make sure it doesn't shoot up real fast. Again, if you get to 160, you got a problem. So if it's climbing quick, let's not let it get to 160, right? If she jumped up to 140 like that, I'm probably saying, hey, I don't like it. I don't like it. Let's turn it off. That was a product lube assembly. This one gave us problems. This is Lake Spence. I think Roger showed some photos of Lake Spence earlier. This is different. This is a below grade discharge. This is an oil lubricated assembly. So right here, we're feeding oil into this oiler nut. This oiler nut actually has a bearing in it. Really hard to see from this grainy photo I've got, but there's a bearing right here. So I actually would, in this scenario, be interested in what the temperature is in this housing. I want to be as close to the bearing as I get. So if you got an exploded view, a cross-sectional view like this, it pays to know where my bearing is. That's where your heat's gonna generate from. This one, we run two flush lines, two oil lubrication lines to that oiler nut. One was a drip system, feeding a constant drip. One was an emergency. This one got hot on us, so we ran an override line so we could dump oil in there in that scenario. We wanted to flush as much oil as we could in there, because oil in this type of pump is lubrication, right? Good point here. If you show up and that oiler has not been running, you got a brand that is open at that point. I think that's in my confirming flow slide. Am I good? Okay, yep, next, confirming flow. So that check valve's got an indicator right there. Is it open? Is it down? And what position it is. I don't know if that pump's running or not, but that indicator is up. That doesn't really tell me if that's open or closed. You gotta look at these things before you turn on, right? and I get this all the time. I'm walking around before you press go, and they keep saying, "Are you ready? Are you ready?" And I'm not telling people what I'm doing, but I'm just, I'm asking myself, okay, does that look good? Does that look good? Does that look good? What position is that indicator in? Things like that. What's the zero on my pressure gauge? Is it really zero, or is it 10 psi? What's it stuck at? Because when it turns on, I can't go back to before it was running. So confirm flow, an indicator on a check valve may tell you that. Flow meter may tell you that. So there's a flow meter set up there. Sound, I've hit them all so far. And then did I see the water come out the end? That one was really easy to tell it was pumping. Pressure readings, okay, you have a pressure drop across a valve. Not a great way to do it, but if I had a valve that was in transition, Abilene was this way. We're seeing 140 on our line, and I'm seeing 170 on my gauge. Well, that's telling me I got some friction loss going through that pipe. That valve is cutting, is adding some head, so I got flow. It's telling me I got some flow through there. Double check your check valve position. Okay, so yeah, we think we got flow, but is the valve open? Again, you may see a closed, you may see an open, it may have the words on the side, it may just be a lever that's tough to, lever, where am I from, Britain? It's tough to tell in what position it is, unless you see it before it starts. These weighted checks, that's pretty easy. You know when that's open. Sometimes these valves, right? I'm trying to see if I've got flow. A check valve with a rising stem like that clay valve style, you'll see that stem come up through the assembly. That'll tell you it is open. It is closed if down, things like that. These things freeze up all the time, or the balance line feeding pressure back through is cut off and it's not opening correctly. Maybe I've got a light indicator on my valve. Green normally means open, red means closed. You may see things like this. It's a high quality photo there. How about that? Open, closed, if it's something like that. Okay, we already talked about pressure gauges, but again, we're going to verify our suction and discharge pressure. On a vertical turbine pump, do you have suction pressure? Sometimes. Explain. I wasn't expecting sometimes. Yes or no, maybe. If it's in your can, yeah. And that can is flooded?
Yeah.
Yeah. What if it's in a lake? You actually do have suction pressure. It's water over the bowl assembly. That amount is suction head over the impeller. So we want to make sure that does not go to zero or doesn't pull a vacuum. We might see a vacuum on split case pumps. We should not see a vacuum on a vertical turbine pump. That's probably bad. But we definitely should not run out of water in our sump. If you're over a wet well, we need to pay attention to that suction pressure, how much it's flooded. And again, check your units. The formula here, you got your pens, write this down. This is important. Head or pressure in PSI is equal to 2.31 times the pressure in feet of water. Okay, so a lot of our gauges, we like to read in feet of water. It makes calculation easy. I've got feet of water, on my discharge side, and I can measure down to the water level. It's a pretty easy calculation to approximate TDH and then tell us where we're running. But a lot of these gauges are in PSI. This one is in inches of mercury, and it's a combination, inches of mercury and PSI. Pay attention to dual scale gauges. I showed that because the red here is pounds per square inch. I know y'all can't see this. And the black is kilograms per square centimeter. Same thing, PSI in black and bars in red. I don't know what a bar is. I think I learned it at some point, but I don't know. So we either talk in PSI or feet of water. All right. So you've checked your pressure. It made sense. We're working through, right? So next thing I'm doing, and conveniently, it's pretty much that way on your form. I think it goes to electrical data first, and then to flow and head. But really, we're just checking before we're reading. If I've got good flow, I'm not hot in about 10 minutes or so of running. If they can give you 10 minutes to run, at that point, I'm going to go to my MCC, and I'm going to record my amps and volts, or I'm going to go put my amp meter on there and record my amps and volts. Because an important one, if we're overloading the motor, you can cause damage. What do I mean when I say overload? Too many volts?
Too many amps.
Too many amps, that's right, not volts, amps. Amps, full load amps, FLA, we already talked about that. That's a setting based on the motor. Every motor has a full load amperage. Don't confuse it with service factor amps. At Smith Pump, we always want you to run below the full load amperage. A cheaper pump company, they might let you go to service factor, not us. Okay, so you're below the full load amperage. I show these devices, these MCCs, because they're not very easy to navigate. And there's probably 24 different varieties of these we see. The most common one is this GE 469. How convenient of GE though, they discontinued that model, so you can't get that. Now they're this new GE 750. Don't pay attention to the letters there. That's a GE 750, which works about the same. It even looks about the same. It's just got a little different indicator lights on the front. But get familiar with how to navigate through there. And I'll share with you, menu takes you back, and then there's normally an enter button. Enter will advance you down, and then you arrow over and get to what you're looking for. You should have already done this in your pre-start. You should have already confirmed the setting parameters are in there. Okay, and if you did that, you got familiar with where to go see. There's an area, you got actual status, and then I think it's got metering, and then there's set points or something like that. You want to go to the second menu called metering, and you want to advance down in there, and you can pull up the amp screen, and it'll show it on you, and you can just keep it up there. And then you go in and you look and you see your amps. Okay, so at that point you can write that amperage down on your form. I know I'm getting boring. Hang with me. You can write that amperage down. Do you want to do all 3 legs of amps or just one? What if it gives you an average, and what if it gives you all 3? What are you writing down? Write down what you can get. What if you can get both, Joseph? What are you writing down?
Get it all.
Write the 3 legs. It's important that motor be balanced. We got a problem if it's greater than 5% imbalance, and we can't tell that if you just wrote down the overall. Okay, write them all down. I don't care about average. I can calculate that. We do sell a new drive called Danfoss. They've got a different MCC, different settings to navigate through there. I can't tell you how it works. I haven't used one yet. We'll get there. You have? Okay. Is it pretty easy to navigate?
Yeah, they're easy.
Sweet.
It's very similar to an Eaton drive. If you've ever used one of those small single button Eaton drives, very similar.
Oh, I hate the single button. That's terrible.
Well,
or 2 buttons.
It's the circle button. It's got 3, up and down, side to side, and enter in the center. Very similar.
I think I skipped something, but I can't go back. Okay, so
You can on this one, down the bottom.
touch it.
I think you've been in the office too long, man.
Yeah, right. Is it cold beer 30?
Oh, no, it won't.
Okay.
I'm just kidding, I won't let you.
Okay. Thank you, Crystal. Okay, so we're checking our speed. we should expect to see what we're asking for. This one's telling us 810 RPM. That's probably not a nominal speed. That's probably not running at 100 hertz or 100% full speed. But go ahead and write that down. Okay. So at this point, we've checked flow. We've watched our temperature. We've gone through that, and then we've gone to our drive. We've got our amps, our volts. We're back at the pump, and we're going to check our speed. Make sure we know the speed. Don't do speed after you do vibration, because if you do, what if that speed changed during your collection? It's all your data points are kind of invalid. So I'd go ahead and record speed there, and then right after that, write down your flows and your pressures. Okay, that initial check, we weren't really writing it down. We were just confirming. We wanted to make sure there was water going through so it didn't burn itself up. And then check speed. You've already put that tachometer strip on there. If you're running, can you get speed? No, probably not. Well, I say that different. If you're running and you did not put your reflective strip on there, you can't really go back and add it at that point. Don't try and record it on a bolt. Don't just pray that there's a strip on there. you can't get it at that point. Okay. All right, and then we're making a second adjustment on our packing. Okay, so I would hope we made a first adjustment before this. If we had that much spray, we should have tightened it then. If you got that much spray, there's a chance it gets up in your motor. It's going to make a mess of the job site too. So make it a little less initially. Then make a second adjustment if needed. If not needed, if you're running cool and you don't have any leakage going through there or minimal, it's okay. Okay, we've already collected some readings, but I wanted to talk through that form because I got a whole lot of things to tell you here. There's a lot to what you're going to record in there. Son of a gun. Okay, if you need to go to the restroom, go to the restroom, but then meet me in the back of the shop. Okay, we're going to keep going on that test pump. Crystal, how do I export the video?